any logical function has to be implemented into a logical circuit, right? That is what a logical function is all about. So in order to have a logical function, you need a logical expression, right? For example, AND gate. AND gate, what is the logical expression for AND gate? Can I ask one person, Sri Kiran, can you please tell me what is the logical expression for an AND gate? Logical expression. So this is the basic properties. Okay. So by using Sri Kiran, can you please respond? What is the logical expression for an AND gate? Sri Kiran, are you there? The others, I think you can give it in the chat. What is the logical expression for AND gate? Sri Kiran, are you there? Can you please respond? Sri Kiran.
Sir, A plus B.
A plus B, eh? I'm sorry, Sri, it is A dot B. Right? A plus B is OR gate, ma. Right? So logical expressions are basically classified. Okay. The logical expressions are basically classified into two types. One is called the sum of product. Okay. Any logical expression in the world is classified into two major categories. One is called sum of product, or it is product of sum. Okay, so please keep this in mind. Any logical expression has got two major types. One is called SOP. SOP stands for what? Sum of product. Okay, and POS, the second one is POS, that stands for product of sum. Definitely you would have already done with this topic previously, but still I just want you to brush through the topic so that you will be able to implement logical circuits using logical expression. Okay, so in order to classify this into two types, they are basically, these are the characteristics of sum of product and product of sum. Okay, SOP stands for sum of product and POS stands for product of sum. Okay, and basically it has got a procedure in order to construct the logical circuits. Okay, now can you tell me what is required for constructing a logical expression? You use logic gates, right? What are the two major gates which is used for constructing a logical expression? What are the two major gates which is required? NAND gate. Pallavi, NAND and NOR are universal gate. Good. But what are the two major gates which are used for constructing a logical expression? That's okay, Pallavi, that's okay. Any other answer? Very good. It's and or. Okay. So any logical expression, we can use and or logic to construct it, right? So this sum of product can be used with OR gate, and after that you can use AND gate. Okay, OR gates are employed after the AND gate. Okay, in sum of product, please remember you have to implement OR gate after the AND gate, and for product of sum we use AND gate after the OR gate. Okay, this is the thumb rule. I think uh, technically speaking you should have already done with this topic previously, so I hope and believe that you can identify the expression for sum of product and product of sum. If not, also we will just brush up through the topic in this class. Okay, and we'll see how the functionality of a logical expression is defined. Okay, so is that clear? Everybody, is that clear? So every logical expression comes in two major categories. Either it should be a sum of product or product of sum. Okay, and these are the fundamental elements which are used for constructing the integrated circuits. Okay, so let's look at a simple example. This is a simple example for SOP. Sum of product stands for SOP. Now, why it is called SOP is you look at this element called plus. Okay, this is sum operation. So sum is used in between the products. Okay, if you look A dot B bar, B dot C dot D. So this is a product. Okay, so in between the products, you are using sum. So that is why it is called sum of products. Is that clear? And when you are implementing this as a function, this is how the logical circuit diagram looks like. Okay, so A B bar. So this is actually A B bar that is multiplied using AND gate. So the output of this is what? Can I have Mr. Naveen Kumar? Naveen Kumar? Naveen, you're there? Naveen,
Yes,
can you
sir.
tell me what is the expression for this output of this gate? This is the gate. What is the output expression? My input is A, B bar. So what is the output? Naveen,
Yes, sir.
what is the output for this expression? What is this gate?
Sir, it's or sir,
It is not XOR, it is AND gate.
and later.
So AND gate, what is the expression? The input is A, B bar. So what is the output?
B bar.
Pardon?
Uh,
AND gate, man.
B
So
bar,
what is the expression?
B bar B, sir.
A,
B bar B.
A bar B. No, it is A dot B bar.
B dot B bar. Yes, sir.
Okay. Yeah. What about this thing, Naveen? Second gate. What is the expression? For this gate, what is the expression?
Sir, your voice is breaking, sir.
Okay. Is it clear now? What is the expression for second gate? If I name this as 2, what would be the expression for second gate? Naveen,
Yes, sir.
what would be the expression? What is the input here? B, C, D. So the expression is B. What gate it is, Naveen? What is this gate, Naveen? Naveen, what is a gate? What gate is that?
Morse.
Which gate is that? What gate is the gate number 2? Which logical gate is that? Okay, I'll move to Ritvik. Ritvik,
Sir,
Ritvik, what gate is that?
AND gate, sir.
AND gate. So what is the expression?
B into C into D, sir.
Yeah, B into C into D. Okay, what about the third one?
AND gate, sir.
What is the expression then?
A into C.
A. Input is what, man? Look at input and tell. What is the input? Ritvik, what is the input there? A dot C, right?
Yes, sir. A dot C.
You told B into C.
Sir, A into C only, sir.
A into C, right? So this is the input. So when you, this is what? This is all product, right? And you're using an OR gate. So your output would be A bar, A dot B bar plus B plus C, B dot C dot D plus A dot C, right? So this is sum of product. Thank you, Ritvik. So this is sum of product, okay? Or in short, it is called SOP. And the product of sum is over here. It will have product term, this is dot product, and sum term in between. Okay, that's how you find out sum of product and product of sum. I'm sure that already you would have done it in your digital electronics paper, but still, I'll just brush it up. Can I have Mr. Jeevan? Jeevan, you're there?
Yes, sir.
Jeevan, what gate is this? And what is the output of this gate?
So that's OR gate and the output is A plus B.
A plus B. Good. What about the second one, Ma?
Yeah, second one is also a OR gate with a 3 input
So what would be the output?
and it's B plus C plus D.
Yeah, B plus C plus D. What about the third one?
Yes, sir. That's also a OR gate and it's A plus C.
So what is the output there? Your expression?
A plus C.
A plus C. Okay. What would be the total sum output for this? What is the total output of this P?
B. Yeah, sir. It's A plus B.
A plus B dot,
into
yeah,
B plus C plus D.
D dot
into
A plus C. Is
A
that
plus-
clear? So what type of expression is this? What type of logical expression is this?
That's a product of sum.
It's called POS, right? Product of sum. The previous one is what? What type it is?
That's sum of products, sir.
Sum of product. Very good. Ma. So I think already you should have done this thing previously. So this is how you try to draw the logical circuit for a logical function, or you implement a logical expression using this logical circuit. Is that clear? So sum up, we have seen what is logical expression. What are the two types of logical expression? Okay, that is product of sum and sum of product. These are the two types of logical expression. And how do you represent the logical expression using a logical circuit? Okay, so that is how you do it. So this is the general representation of a logical function into a logical circuit, right? So far I think it's all basics. So we will go into a very simple exercise. This is AND gate. All of you know this is AND gate. Can you tell me what is the expression for XOR gate using AND and OR? Can you tell me what is the expression for XOR gate using AND and OR? I request Infant. Baiju Infant. Others, you can give it in the chat. What is the expression for this XOR gate using basic logic gates? Mr. Baiju Infant. Is it, am I right? The name is Baiju Infant, right? Yeah. I'm not able to see the full name. Baiju, you're there? Yeah, Ruby has hit it sharp. Okay, good, Ruby. That's right answer. Baiju, are you there? Okay, Baiju, I'm not sure why his audio is not working. Baiju, are you there?
Yes, sir.
Yeah, Baiju, can you please tell me what is the expression for XOR gate using basic logic gates? This is what gate is this, Baiju? I'm talking second one over here. What is this gate?
XOR gates.
XOR gate. Okay. Now, if the input is A and B, what would be the output? This input is A and B. What would be the output? I want it in terms of logical expression. If the input is A and B, Baiju, what would be the output? I think Ruby Grace has already done it. I think my network issue.
A dash B plus
A dash B plus
plus AB dash.
AB dash. Okay. All of you, can you please draw the diagram and see for that? Okay. Do it later, not now. So similarly, the next one. Thank you, Infant. Can I have the next person? Mr. Who's the next person? Need some name. Yeah, Shiva Shiva, you're there? Shiva, can you tell me the expression for XNOR gate?
A dot B plus A bar dot B bar, sir.
Very good. A dot B plus XOR bar. Okay, thank you, Shiva. And the last one, Ilakya, you're there? Ilakya? Ilakya, can you tell me the expression for mux? Now, what type of mux is this? How many inputs? How many outputs? What type of mux? Just tell me what type of mux is this? Ilakya?
Sir,
Yeah. How many inputs are there? How many outputs are there, Ilakya, for this mux? How many inputs? How many outputs? I'm just asking. Look at the picture, you can tell. How many inputs? How many outputs? Ilakya? You're there?
input,
2 inputs. Okay. How many outputs? Only 2, Ilakya. Are you sure?
sir, please.
You have select line also as input, Noma. So mux will have 3 inputs, okay, and 1 output. But it is called 2 cross 1. Okay, it is called as 2 cross 1 mux. Why? Because it has got 2 inputs and 1 outputs. Okay, it is called 2 cross 1 mux. Okay, and the select line, the third one is an input is a select line. The select line is used to select any one input. Okay, if the select line is 0, okay, if the select line is 0, automatically there will be a switch inside. Okay, there will be a switch kept inside. If the select line is 0, the switch will close. Okay, and it will select A. Okay, is that clear? So the input would be connected over here and the output will come across this. Okay, and if the select line is 1, then B switch will be closed and the output will come across this. Okay, so the output expression, the expression for this mux is given to be A S bar. Okay, S bar, because this is given the input 0. Okay, plus the second one is B yes. Okay, so this is the expression for 2 cross 1 mux. Okay, so there are 3 inputs. One is select line, the other 2 are the inputs. Okay, now can I have Mr. Rishi? Rishi, you're there?
Sir. Yes, sir, I'm there.
Rishi, if I want to make a 4 cross 1 mux, how many select lines will be there? If I want to make a 4 cross 1 mux, how many select lines will be there? If I want to make a 4 cross 1
Sir, your
mux,
voice is
how many
breaking.
select lines will be there? Your voice is only breaking, Rishi, for me. If I want to have
2 select lines.
sorry, I've told the answer. If I want to have, how do you say 2? 2 is right. How do you say 2?
Two select lines, sir.
Ruby also gave the answer 2. How do you say it is 2? Your answer is right. How do you say it is 2? That's my question. How do you say it is 2? Okay, if it is 8 cross 1 mux, then how many select lines? If it is 8 cross 1 mux, then how many select lines? Yeah, that's right. It is depending upon the number of inputs, ma. Okay, so please remember this. It depends upon the number of input. The select line is determined by the number of inputs. Okay, so if the inputs, it is based upon the logic 2 power n. Okay, if your n value, for example, if you, this is the total number of select lines, n is the number of select lines here. N is the total number of select lines. For example, if the input is 2, then how many select lines will be there? N should be equal to, if the input is 2, the select line is going to be 1. Okay, so this is equal to the number of inputs. This is equal to the number of inputs. So if the number of inputs is 2, then your number of n value is what? N value should be 1, right? This is the total number of inputs. So this is equal to the total number of inputs. So whatever is it, you can just find it out. If it is 8 cross 1, then it should be 3 input select lines. Okay, I think hope you would have done the fundamentals previously. So this is how you do it. So this is how you get the expression for a 2 cross 1 mux. When you look at it, you have only multiplication, and that is AND gate and OR gate required for constructing a mux. Okay, this is as far as combinational logic circuit is concerned. Now when you go to sequential logic circuit, okay, all of you would have studied, there are 2 types of circuits there. One is called combinational logic circuit, the other one is sequential logic circuit. Okay, in sequential logic circuit, we basically have flip-flops coming into play. Okay, flip-flops and latches, these are the 2 elements that are used for constructing the sequential logic circuit. Why? Because this flip-flop and latches are required is they act as a feedback element. Okay, generally your combinational logic circuit, that is your AND or XOR, everything works on the combinational logic mode where they depend upon the present input and present output. But in sequential logic circuit, it depends upon the present input and the past input. Okay, which means that there is a memory element or a feedback element there. So for the memory element, we use all these flip-flops. Okay, JK flip-flop, D flip-flop, T flip-flop, SR, all these things you should have done it previously, but just a recap we are doing. Okay, so these sequential elements uses these flip-flops as a memory element to get the operation done. Okay, so this is a sequential table for D flip-flop. What is the other name for D flip-flop? Anybody? What is the other name for D flip-flop? Anybody? What is the other name for D flip-flop?
Delay flip-flop, sir.
Yes.
Delay flip-flop, sir.
Who's that? Number 44. What's your name, ma?
Abhishek, sir.
Abhishek, that's right answer. It's called delay flip-flop. Okay. Now, what do you mean by delay flip-flop is whatever input you give. Okay. Whatever input you give in the data, that will come across the output after 1 clock pulse. Okay. So clocks are the extra element which is used for the synchronism operation for the data output. Okay. So D means delay flip-flop. Okay. So similarly, we have SR and JK and T and flip-flops available. So everything have got its own merits and demerits. Hopefully you'd have done everything in the previous semesters. So I'm just brushing through it. And we also build up this excitation table in order to build up the sequential table, right? So when you look at, I think this we can do it as a weekend work. We'll just give you this at the end of the weekend, how to construct everything using other logic gates as well as the excitation table. So that would be your weekend work for this particular class. So to sum up what we have learned so far, we have learned what is a logical expression is, how to implement a logical function using a logical expression, and how do you implement it in logic circuit. That's what we have learned for this particular class. Okay, and we also have learned the types of logical expression, that is product of sum and sum of product, and we saw some examples how to write the logical expression and how to construct a logical circuit. So they can ask you, they will give you a circuit and they can ask you what type of logical expression is that. Okay, so you can just tell that, and after that we have gone in to learn what is a logical, how do you do with the logical expressions, like how do you get the logical values from the logical expressions. And also we went in to study the types of circuits, two types of circuits. One is combinational logic circuit, the next one is sequential logic circuit, and in that we have seen how the basic gates and how do you implement the gates, that is using and OR logic. How do you implement all the logic gates? You've seen an application with MUX. How do you do it with MUX? And last we saw what is sequential circuit and how are flip-flops used and what are the various types of flip-flops, right? That is the whole brief of what we have done for today's class. We'll be working on